So yesterday we have seen the strength of acids and bases we can express using pH scale. So in pH scale, the neutral substances have a value of 7 and acidic substances will have a value less than 7 and basic substances have a value greater than 7. So how can you determine the pH? There are certain so many methods are there. Then in your ordinary labs, what you can do is you can use pH papers and you can find out the color change, and then you can find out the pH of the solution. For pH 7, usually the color will be green. Then pH, if it is less than 7, that is acidic range, it will be from orange to red, yellow, then orange, then red. Okay. Then if pH is greater than 7, that is basic range, slowly it changes from bluish green to blue to violet. Okay, so for the strongest one it will be violet. Here for strongest acids it will be red. So we will see. See what I have taken is, this is a pH paper. See these are pH papers. You see the pH paper, it is green in color. So here you see colors are given, red, then yellow color decreases, then see for pH 7 it will be green, and for pH 10 it will be violet. So what we do is we take a piece of pH paper, we will take, it is which is green in color. See the pH paper is taken. Then we will keep it here in the watch glass and we will add and we will see the color change. Okay, I will show the color change after putting in each solution, that is both basic and acidic solution. So I have taken, so in neutral water it will be having the same color, green, pale green. Okay, in neutral water it will be having the same color. Now what I am doing is, see, I am adding HCl. See, in HCl it is, see the color change to this one. Now what we do is we take this and compare the color. It is 0 or it is 1. Light red it is 1, it will be pH. pH will be 1. Now we will take ethanoic acid. Ethanoic acid. See the color change. Now green change to yellow. Now it is yellow in color. Okay, the green change to yellow in color. We will take the pH paper, pH strip, and compare it. It is pH 2. See, this will not be accurate. It will only approximate. Okay, pH is 2. Now we will take a base. This is sodium hydroxide. I am taking sodium hydroxide and see the color change. It is violet. So we will take the pH, that violet it is, see, 14 or nearly 10. Let's say the pH is 10. Not 10, actually it is 10, pH 10. Now we will take sodium carbonate solution. Sodium carbonate solution we will take. And we will add here. See the pH is slightly blue, very less blue in color. Understood? So that is the color change. Then you can compare it with the color here. It is pH 9. pH only 9. See the color. So that is the difference. So using this you can find out the pH, but this pH paper, measuring using pH paper, is not that accurate. It is a little bit approximated. Okay, so these are the color changes. Now we go to the pH. What is the use of pH in our daily life? See, our body is accustomed to a pH to 7 to 7.8. See, if pH become more than that and all, this will change. Our body will have some reactions. Now in our rain, pH of as usual rain is 5.8 like that. If the pH value of the water which is coming from rain is less than that, then we call it as acid rain. If acid, we heard of acid rain, it is destroying the cultivations and all. And how are acid rains produced? Acid rains are produced by the dissolving of acidic oxides like nitrogen dioxide, sulfur dioxide, etc., which are present in the air or which are formed in the air from exhaust gases or from the industries. When their exhaust gases comes to the air, some of them will contain this sulfur dioxide or nitrogen dioxide, etc., which when dissolved in water will give you an acid. And if the acid comes along with the rain, we call it as acidic acid rain, and this acid rain destroyed the vegetations, etc. Because, and we call it the acid rain if the pH is less than 5.6. Okay, now that is one thing. Now another, our stomach has, you know that HCl is there in our stomach, and there is a particular pH for the stomach also. If this pH, when we eat spicy food, in our stomach there is acid, so our stomach is accustomed to a certain pH. When we eat a lot of spicy food, ഒരുപാട് എരിവും പുളിയും ഒക്കെയുള്ള ഫുഡ് കഴിച്ചാൽ നമ്മുടെ വയറ്റിനകത്ത് again and again acids will be produced. Then pH will go beyond that particular pH our stomach can withstand. Now what sometimes happens is when this concentration of acids increases, that is pH go beyond a certain limit, our stomach will have pain, then irritation, etc. will be there. ഒരുപാട് ചിലർക്ക് വയറ്റിന് പോകും, ചിലർക്ക് വയറിന് പ്രശ്നങ്ങൾ, വേദന ഒക്കെ ഉണ്ടാവും. Then we call it as hyperacidity. In that case, what we can do is we can drink very mild bases. Usually doctors prescribe milk of magnesia, that is magnesium hydroxide. You might have seen gelusil syrup and all. They are actually a suspension of magnesium hydroxide, and this magnesium hydroxide is a weak base. It can neutralize the excess acid present in the stomach. So അതാണ് നമ്മൾ ചെയ്യാറ്, വളരെ വീക്കായിട്ടുള്ള ബേസ് കഴിക്കുക. അല്ലെങ്കിൽ നമുക്കൊരു കാര്യം ചെയ്യാം, ഈ സോഡിയം ബൈകാർബണേറ്റ്, അപ്പക്കാരം എന്നൊക്കെ വീട്ടിൽ ഉപയോഗിക്കുന്ന സാധനം, അത് ഒരു ജസ്റ്റ് ഒരു പിഞ്ച് ഓഫ് സോൾട്ട് യു ടേക്ക് ഇൻ എ ഗ്ലാസ് ഓഫ് വാട്ടർ ആൻഡ് യു ക്യാൻ ഡ്രിങ്ക്. ദാറ്റ് വിൽ ഓൾസോ ന്യൂട്രലൈസ് ദി ആസിഡ് പ്രസൻറ്റ് ഇൻ ദ സ്റ്റൊമക്ക്. അങ്ങനെ നമുക്ക് വീട്ടിൽ പെട്ടെന്ന് കിട്ടുന്നൊരു സാധനമാണ്. ഇപ്പോൾ മിൽക്ക് ഓഫ് മാഗ്നീഷ്യ ഇല്ലെങ്കിലും നമുക്ക് അപ്പക്കാരമൊക്കെ ഉണ്ടെങ്കിൽ ഒരു നുള്ളെടുത്ത് ഒരു ഗ്ലാസ് വാട്ടറിലിട്ട് കുടിച്ചു കഴിഞ്ഞാൽ നമ്മുടെ വയറ്റിൻ്റെ പ്രശ്നങ്ങൾ കുറേയൊക്കെ ഈ hyperacidity problems we can solve. So that is such substances which are neutralizing this excess acid, they are called antacids. They are called, the drugs are called, medicines or drugs are called antacids. Antacids usually neutralize the excess acid present in the stomach, and അത് അങ്ങനെ കഴിഞ്ഞില്ലെങ്കിൽ, if you are not neutralizing that excess acid, the problem is it will react with the inner walls of the intestine and ulcers will be formed. അപ്പോൾ അങ്ങനെ എന്തെങ്കിലും ഉണ്ടായാൽ ഉടനെ തന്നെ ആസിഡിനെ ന്യൂട്രലൈസ് ചെയ്യായിരിക്കും the best way. Now next, our tooth, നമുക്ക് സാധാരണ എപ്പോഴും ഉണ്ടാകുന്നതാണ് tooth decay. What is tooth decay? Suppose we are eating food and not washing properly our mouth. What happens is food will be accumulated there in between the cavities, and during the night time or when for some time if it is there, these food particles will be dissociated by bacteria present in the mouth and acids will be produced. These acids, our tooth can withstand only a pH of 5.5. When the acids are produced, pH will again come down. So what happens is this excess acid will start to react with our teeth and it will destroy the calcium phosphate layer of our teeth. അപ്പോൾ കുറേ കാലം കഴിയുമ്പോൾ നമുക്ക് പല്ല് പുളിക്കാൻ തുടങ്ങും, ടൂത്ത് ഡീക്കേ ഉണ്ടാകും, ഇതൊക്കെ ഉണ്ടാകും. അതിനെ പ്രിവെൻറ്റ് ചെയ്യാൻ എന്ത് ചെയ്യണം? ടു പ്രിവെൻറ്റ് ദിസ് tooth decay, what you can do is you can use toothpaste containing bases. So toothpaste containing bases can destroy or you can neutralize the excess acid present in the mouth. അപ്പോൾ എന്നും നൈറ്റിൽ ബ്രഷ് ചെയ്യണം. ബ്രഷ് ചെയ്യുമ്പോഴും എന്ത് ചെയ്യുക, the use paste you containing bases. അപ്പോൾ അതൊന്ന്. പിന്നെ our cultivation, our even the soil has a particular pH in which the plants can grow healthily. If we can if the pH of the soil changes, എങ്ങനെയെങ്കിലുമൊക്കെ എന്തെങ്കിലും ഒരു കാരണം വഴി ചേഞ്ച് ഉണ്ടായാൽ, പി എച്ച് ചേഞ്ച് ഉണ്ടായാൽ, വി വിൽ ഹാവ് ടു ന്യൂട്രലൈസ് ദാറ്റ് എക്സസ് ആസിഡ് ഓർ ബേസ്. ചിലപ്പോൾ ഒക്കെ നമ്മുടെ പിന്നെ പാടത്തൊക്കെ ആണെങ്കിൽ ആസിഡിൻ്റെ പെർസെൻറ്റേജ് കൂടുമ്പോൾ വാട്ട് ദേ ഡു ഈസ് ദേ ആഡ് ലൈം. Lime will be added to neutralize the acid. That is another thing. Okay, so these are the and the insect bites. See, always the insects, when they are biting us, we get an irritation. Ant biting, bee biting, etc. They all stings of this bee. They all cause this irritation because in them present the acid. So acid, when it enters in our body, we feel the pain and irritation. Okay, so these are the ways in which pH affects our daily life, or pH is important to our daily life. Okay, now about pH ne kurichu nammal paranju. pH, if it is 7, it is neutral. Ini anganeyulla 7 neutral aanengil, if pH is 7, then pH paper na color, the color of the pH paper will be green. If pH is less than 7, the substance is acidic and the color of the pH ranges from yellow to red. And if the pH is greater than 7, it is basic. Then pH color of the pH paper will be from bluish green to violet. So this three nammal kazhinju. Now we are coming to salt. Now what are salts and how are they obtained? Salts are produced when an acid is neutralized by a base, or when an acid reacts with a base you get a salt, or when a metal displaces hydrogen from acid we get a salt. When a metal reacts with the carbonates or bicarbonates you get a salt. So salts are substances which when an acid neutralizes a base we get, or when hydrogen of the acid is replaced by a salt. For example, HCl, when hydrogen is replaced by sodium you get sodium chloride, a salt. Potassium, H2SO4, if two hydrogen are substituted by two metals, that is K2SO4, a salt. When two HNO3, instead of one hydrogen, if you add a sodium, it is sodium nitrate, a salt. So salt can be obtained like this also, by either by neutralizing an acid by a salt, or by replacing an hydrogen of the acid by a metal you will get a salt. So these salts, now next what we come to is salt. Now salts are how they are produced or how they are prepared. That is what we have some important salts. First important salt we are going to see is sodium chloride. Sodium chloride, NaCl. See, the sodium chloride is a very important salt and it plays a very high role in our daily life. As sodium chloride we are consuming it, then, or sodium chloride it is used for preparing so many chemicals. It's cheaply available. See, sodium chloride നമുക്ക് ഈ വളരെ ഫ്രീ ആയിട്ട് സീ വാട്ടറിലുണ്ട്. സീ വാട്ടർ ഈസ് എ വെരി ഗുഡ് സോഴ്സ് ഓഫ് സോൾട്ട്. അതല്ലാതെ സോളിഡ് ഫോമിലും ഉണ്ട് സോൾട്ട്, sodium chloride. They are in some places sodium chloride salts are there, rocks are there. So sodium chloride is also called rock salt. It is also called rock salt. This sodium chloride ആയിട്ട് തന്നെ rock ആയിട്ടിരിക്കുന്നത് കാരണം, then we call it as rock salt. Then this sodium chloride is present in sea. By the evaporation of seawater we can get sodium chloride. Understood? So now the question is what we are going to study is, from this cheap sodium chloride what are the chemicals you can manufacture. The first one is sodium hydroxide. Sodium hydroxide or NaOH. It's a very important chemical used for the manufacturing of soap and so many other things. Sodium hydroxide is manufactured. So what we are using, how sodium hydroxide is manufactured from sodium chloride. See, a solution of sodium chloride is called brine solution. Brine solution. It's an aqueous solution of sodium chloride. It's called a brine solution. Now through brine solution, electric current is passed through it. So sodium chloride NaCl plus H2O. Through this mixture or the solution of sodium chloride in water, through this electric current is passed. Electricity is passed through it. Then what will you get? You will get sodium hydroxide in the electrolyte, and you will get chlorine at the anode and hydrogen at the cathode. So these are the products you will get. You will get when electricity is passed through brine solution. What is brine solution? Brine solution is an aqueous solution of sodium chloride. So through an aqueous solution of sodium chloride, when electricity is passed, you will get sodium hydroxide in the electrolyte, or near the cathode actually, electrolyte near the cathode, and the chlorine you will get at the anode, and hydrogen you will get at the cathode. You will get the hydrogen at the cathode. Now, this process is called a chlor-alkali process. It is called a chlor-alkali process. Now, what is this chlor-alkali process? Since chlorine and alkali both are formed in the reaction, it is called a chlor-alkali process. So, using chlor-alkali process, you can manufacture sodium hydroxide. The electrolyte is taken out, it is crystallized, you will get sodium hydroxide pellets. Now, what are the uses of these chemicals? There are so many uses for each of these. You know that hydrogen can be used as a liquid fuel. It is used for the manufacturing of hydrogen chloride gas. It is used as a reducing agent in metallurgy. And chlorine is used for bleaching purposes. Then sodium hydroxide is used as an alkali as an alkaline reagent. Then it is used in the soap industry. Lot of uses are there for each of the reactant. Okay. So this is chlor-alkali process for the manufacturing of sodium hydroxide. So it is manufactured by chlor-alkali process. What is chlor-alkali process? The electricity is passed through brine solution. Brine solution is an aqueous solution of sodium chloride. You will get sodium hydroxide, then electrolyte near the cathode. You will get chlorine at the anode and hydrogen at the cathode. Okay.